Hope you are doing great. People who are going to write the exam for the upcoming days, this video will be very much helpful for you. Let's get started with the analysis of January 23rd, shift 1 and 2. The correct order of ionization energy of chlorine, sulfur, phosphorus, aluminium and silicon is given. So ionization energy, very simple trend. We know as moving left to right in the period, it increases and down, top to bottom, it decreases. Right, shells increases and the atomic radii decreases, those reasons. So here we have mix of elements like chlorine, sulfur, phosphorus. And we have an exception also. Let's consider period 3. That is sodium, then comes manganese, then aluminium, silicon, then phosphorus, sulfur and chlorine. Right? But there is an exception of phosphorus and sulfur. You remember phosphorus and sulfur. This is 15 and this is 16. Phosphorus has half-filled configuration and sulfur is having 3p4 configuration. Correct? Which can be easily removed so that sulfur can be half-filled configuration. Can become a half-filled configuration. So, ionization energy of phosphorus is more than sulfur here. So, the correct order becomes Cl will be greater. It doesn't want to give up the electron, so that obviously that is greater, and then comes phosphorus, then sulfur, silicon and aluminium. Okay. The next one, the given below are two statements. Cobalt Br6 complex absorbs lesser energy than the cobalt Cl6 2-, and statement 2 is cobalt Cl6 2- has higher crystal field splitting energy than the bromium complex. Okay, so according to spectrochemical series, which is more Cl- and then comes Br-. Correct. So Cl is strong field ligand, then Br-. So Cl6 2- will have a larger crystal field splitting than Br complex. Right. So what will happen to Br6? Br6 absorbs lesser energy than the Cl6. So statement 1 is right. I'm talking about statement 2. Cl6 is having higher crystal field splitting energy. Yes. So that is also right. 1 and 2 are right. Then this question, mass of the product Cs. They are asking mass. So first let's do this question. What is B? Thin HCl reduction. So NH2 will be formed in place of nitro. CH3 remain intact. Then comes, so many times we have solved this, right? Which will form NHCO CH3 and CH3 will be there. And after that I have Br2. CH3 and this both are electron donating group. This dominates, so I'm choosing ortho position to CH3. They are asking mass by giving 137 gram of the initial product was used. As you can see, which is 1:1. Right. Let's start with the 4-nitrotoluene. That is 137. What is the molecular weight? That is also 137 if you count it. So number of moles of nitrotoluene, that is 1 mole. Okay. And 4-acetamido 2-bromotoluene, the product, which is, the mass will become 228. Okay. So molecular weight is 228, which means this is 1 mole and that will also give 1 mole, that is equal to 228. So 228 grams. Which of the following undergo nitration at the fastest rate? We have nitro, benzene, toluene, benzoic acid and bromobenzene. Okay, so nitro, which is in strongly reactivating group, right? And nitration is an electrophilic substitution reaction. And toluene is an activating group And what about benzoic acid? That is also deactivating. Br group, that is deactivating but still orthoparadonas, but weakly deactivating, I would say. So among this, which has a different property, that is toluene, the methyl group, they are electron donating, it activates the ring towards the nitration, electrophilic substitution reaction. For the following change, H2O gives H2O gaseous state, so liquid to gas. Select the correct answer at 100 degrees Celsius. So the change happens from 5 degree to 100 degree. Okay, so that is the question. So this is a simple vaporization reaction. So vaporization means what must have happened? Heat must be absorbed, right? So Q will be positive. And what about delta H? Enthalpy change. That is endothermic. Correct. Heat absorption. So which of the option matches with this? Q positive, delta H positive. B and C are looking same. I think this must be a negative. I'll give you the values. Q is positive, delta H is positive, and W, the system expands. So W is negative. Okay. Then the next one, with this it is forming X and Y. What is X and Y? First reaction, that is a simple reduction. Addition of hydrogen will happen. Hydrogen, palladium present, so which will give you butane. Right, hydrogen in the presence of palladium undergoes complete hydrogenation. And then next I have NaNH3. NaNH3, you remember, bridge reduction, Lindlar catalyst, cis and trans. The question is asked from hydrocarbons. So this will give you trans product. Bridge reduction. Remember, bridge is for transportation, we told. If that is undergoing the partial hydrogenation also, this one will give you the cis product, butene. So because it is adding up like this, no? Presence of a catalyst. So cis and the trans product we can expect. Then consider the following graph of concentration versus time. Find the half-life of the reaction. So the graph is having all those informations. So initial concentration starts from 0.6 molar, and at time at time 100 seconds, it is 0.55, and 200, that is 50. It is decreasing linearly, so it is in zero order reaction. From 0.6 molar to 0.3 molar, right? That is the half-life. So decrease needed should be 0.3. 0.3 is the difference. If you could see the changes over here for 100 time, that is 0.05 molar per 100 seconds, right? So now I want the change of 0.3 change. So how I can calculate it? 0.5 per 100 second, 0.05 per 100 second, so 0.3 for 600 seconds. Binary solution formed by mixing of acetone. So how that deviation will happen? So acetone with CS2, both are volatile liquids. So this will acetone with CS2, there is no positive or negative deviation can happen, but slightly it can show positive deviation, I guess. It's nearly an ideal solution, but slightly it can show a positive deviation. So choose the graph according to that. Then the next question. 25 ml of 0.1 molar barium hydroxide reacts with HCl. Find the weight of HCl. So barium hydroxide plus HCl. What is the product? Barium chloride with H2O. Balance the reaction. It is already balanced. So 1:1 ratio. Right? So 1:1 ratio. So which will be 0.1 molar of 25 ml. So which is 0.1 into 0.0. 0.0025 converting to liters, so which will be 0.0025 moles. Okay. Sorry, I didn't see the hydrogen and oxygen over here. So which is in 2 H2O has been formed, right? So 2 HCl, that will give you 2 H2O. So 1:2 ratio, correct? 1:2 ratio, so 0.025 moles of barium hydroxide is participated, means double the amount of HCl should be there. So which is 0.005. They are asking weight of HCl. So what we have to do, multiply this with 36.5. So which will give you, I'm not sure whether they have asked in milligrams or grams. So I'm giving you in grams, 0.1825 grams. Consider the two example complexes, chromium oxalate complex, cobalt oxalate complex. Find the ratio of CFSC of 1 to 2 complex. Neglect the pairing energy and the delta naught of both the complexes to be X. So first of all, let's take chromium. The oxidation state becomes 3 plus. So it will be D3 configuration, which is T2G3 Eg0. Similarly for, let's find out the CFSC also. 3 into minus 0.4, that is 0. So which will comes out to be minus 1.2. Similarly for cobalt, which is in D6 configuration. Oxidative is a strong field ligand definitely, so this will become T2G6 Eg0. So the CFSC, that is 6 into minus 0.4, that will become minus 2.4 X. They mentioned neglect the pairing energy and delta naught, that is X. So what is the ratio between these two, 1.2 and 2.4? The ratio is 1/2. The next one, P reacts with NH3 to form C, and C is reacting with Br2KOH and CHCl3KOH to form a complex. What they are asking is, what is P? Okay, that is the question. So as you can see, first one, this is in Huffman bromamide degradation. So there must be in CONH2 amide group, right? And this one is amine to, this is amine. This one, second one is amine to NC, isocyanate, right? So which need to be N? C need to be N C6H5 CONH2. From there NH3. So there must be in carboxylic acid. A and B are mixed and treated with dilute base to give the mixture of products. Choose the incorrect product. Okay, so the first one, I have cyanide group. So upon reduction followed by hydrolysis. So cyanide reduced to form first CH double bond NH. So followed by hydrolysis, that will give you CHO, NH3 will be leaving the compound. In the second one, B would be break the double bond, put double bond O, double bond O. That's for ozonolysis, right, with zinc H2O. So the product is CH3 CHO. This is also an aldehyde, this is also an aldehyde treated with dilute base. What is this? Aldol condensation. So what are the mixture of product can be formed? Because these two are different aldehydes, right? So we can expect, first let's write CH2 CHO as an enolate, so that the another one can be formed, and then another side of CHOH CH2, CH3, and this will leave as in water to form a double bond over here, right? So CHO, CH3, CH double bond, CH2, CHO. This can be formed if this is an enolite, A is an enolite. And talking about B, CH3, CH2, CH double bond. This is with B combines, sorry, A combines, right? Then talking about C, I have CH3, CH2. I don't think this will work. Let's check D also. CH3, so this case will work when this is an enolate, like A is an enolate combines with B. Okay, this will work, and C is not the product, so that is the incorrect product. Correct statement about 13th group. Electronegativity decreases regularly down the group. Okay. Ionic radii decreases down the group. Boron has highest ionization energy. Trichloride of aluminium are covalent in nature. So first of all, talking about electronegativity of 13th group, like boron, aluminium, gallium, indium, thallium, it's generally electronegativity decreases. But here we have a twist at gallium because of the d block contraction. So this is not linearly decreasing down, so which is an incorrect statement. Then ionic radii decreases down the group. So ionic radii usually increases down the group, not decreases, because of the shell increases. So this is an incorrect statement. And boron has highest ionization energy. Boron, it's in the top of the group, right? It's nearer to the nucleus, so which will be having the smallest atomic size, so which will have highest ionization energy. Then trichloride of aluminium is covalent in nature. So it is in dimer, covalent dimer. Al2Cl6 can be formed. So this is also right. C and D are right. Given number of optically active isomer in product. So C5H11 is undergoing a substitution reaction to give product P. So what will be formed? C5H11 OH will be formed over there. So let's try to draw the structures. One, two, three, 4, 5, and then OH, CH3, CH2, 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 CH2. Okay, 8 plus 3, 11. So this can be an isomer, and the next one is, I can put it over here, the OH group, that is 2-pentanol. And the next one can be, I can fix it over here, 3-pentanol. 1, 2, 3-pentanol sorted. Let's play with the methyl group. So 2-methyl, 1, 2, 3, 4. Okay, 3-methyl butanol, 2-methyl butanol, and then other chances can be 1, 2, 3, 4. Can be present over here, and else I can have it on the same carbon. Okay, they are asking optically active isomer in the product. So is there any optically active? This is optically active. This is not. What about this group? This is optically active. This is not optically active. This is having 2 CH3, so which is not optically active. So the answer must be 2. 2 optically active isomers can be formed. The next one, Bayes unsaturation test, steric ammonium nitrate test of alcohol, Stalin's reagent test. So if you know at least the Stalin's reagent test, match that and then come to other test. FeCl3 test for phenol, that will give you purple or violet color, right? And then pink discharge will be there for Bayes unsaturation test. Correct. KMNO4 by adding it, it will go away, decolorizes. And steric ammonium nitrate test, that will be red. Consider the following statements and choose the correct option. Nickel 2 plus forms a pink complex of dimethyl glyoxime. The ligand is DMG. So basically, this will look like this. Hydrogen, carbon, with another nitrogen. Double bond over here and a dimethyl group. Similarly on the other side also, same thing. Which is in 2 plus complex, and this is forming an structure like this. So what they have given is pink color complex. It's a rosy red or almost pink in complex. That is true. And nickel complex with DMG contains 2 ring of 5 membered. That is also right. And nickel 2 plus has a 2 unpaired electrons in the orbital complex. DMG, it will pair. Okay, there won't be any unpaired electrons. That is incorrect. And then nickel 2 plus complex with DMG soluble at pH 9. So that is also incorrect. Only A and B are right. X and Y belongs to group 15. The difference between the electronegativity of phosphorus and X is greater than the difference between the electronegativity of phosphorus and Y. X and Y are. So they mentioned X and Y belongs to the same group. Right. So in 15th group, what are the elements I have? Nitrogen, phosphorus, arsenic, antimony, bismuth. So if you see the electronegativity values, this will be like this. So as you can see, the difference between the electronegativity of phosphorus and X is greater. Phosphorus and X is greater than the difference between phosphorus and Y. Right. So phosphorus, that is 2.39. If I'm taking the electronegativity difference for phosphorus and nitrogen, that is around 0.85. And phosphorus and antimony, if I take, that is 0.14. So that can be your right answer. It's depend on the options you have. Okay. You can also take antimony or bismuth or arsenic, but X will be nitrogen. The oxidation state of chromium in final product obtained in the reaction between Ki and acidified potassium dichromate. So the reaction goes like this. Cr2 with Ki acidified, no, H2SO4 gives, this is a very important reaction. I2 gas will be formed, K2SO4 and H2. So the final product is Cr2SO4 thrice. What is the oxidation state of chromium? This we have solved in our mock test also. So people who have seen our mock test, they must be able to solve this question, which is having the +3 oxidation state. 0.245 grams of organic compound gave 0.5453 grams of AgCl by Carius method. We solved this type of question. Find percentage of chlorine in the organic compound. Right. So very simple question. In Carius method, what will happen? Our chlorines in the organic compound are converted to AgCl, right? So AgCl, what is the mass? 108 plus 35.5, that would be 143.5, right? So mass of AgCl, mass of chlorine in AgCl, that is, I have 0.5453. So 1 AgCl contains 35.5. So I can convert it to 0.5453 into 35.5 divided by the 143.5. Right? So which will comes out to be 0.1349 grams. So the percentage of Cl in the organic compound, then that is 0.1349 divided by, I have 0.245 into 100. So which is equal to 55.06 percentage. Which of the following is incorrect about XCO2F2? Okay, so XCO2F2, what is the structure of that? So Xc, that is 8 plus oxygen, that will be having 6 as a valence electron, 6 into 2, 12, plus fluorine, that is 7, 7 into 2, 14. So it will be 20, 34. 34 divided by 8, which is 4. Remaining I have 2, that will become 1. So 4 bond pairs and 1 lone pair. Right. So let's see what they have given. OXCO bond angle is close to 180. The geometry of XCO2F2, that is trigonal pyramidal, and the C's are shaped with 1 lone pairs on it. Right. So which is close to 180, that is incorrect. OX will look like XC with fluorine on the axial and double bond O with the lone pair on it. Right. So FXCEF bond angle is close to 180. Yes, that is true. Shape of XCO2F2, that is seesaw. Number of valence electrons in XCO2F2 is 16. We have a valence electron of 34, not 16. So which is an incorrect statement. B and C are only right. The given reaction X2 plus Y2 gives to Z. Right. The moles of X2, Y2 and Z are at equilibrium. Okay. 3 mole of 3 mole, 3 mole and 9 mole respectively. This is 3, this is 3 and this is 9. If 10 moles of Z are added to the equilibrium, 10 moles are added to the equilibrium at constant temperature, calculate the moles of Z at new equilibrium. So that's our question. So the new amount will become, this is 3 and this will become 19 mole now. So Kc, that is equal to C square by X and X2 and Y2, right? So 9, 3 into 3, that will become 81 by 9, that is 9. Now what about the new Kc? So after adding Z, amount of X of Z decomposes to turn back to the X and Y, because this is maintaining an equilibrium, right? That I don't know. Amount of how much Z turn back to X and Y, that I don't know. So let me take that as X. So X2 will become 3 plus X by 2, because 2Z. Similarly Y2, that is 3 plus X by 2. Z is equal to 19 minus X. Correct? So just substitute it in the formula. 19 minus X divided by 3 plus X by 2, 3 plus X by 2. So upon solving this, you will be getting the value of, say, would be 15 moles. Okay. Iodoform test can differentiate. So this we did, right? Iodoform test which should have a CH3 group attached with the functional group. That is the rule. So that it can form an iodoform or chloroform, haloform test, right? So methanol and ethanol, yes, that can be differentiated. And CH3COOH, this can be further oxidized, so which can't undergo iodoform test. Propene and butene, that can be differentiated by the iodoform test. And phenol and benzoic acid, so that will also can't be differentiated by iodoform test. So methanol and ethanol can be differentiated. Methanol gives and ethanol will give different positive and negative values. Methanol, that will form HCHO, so that will give you negative value, but ethanol will give you ethanal, that will give you positive value, positive test for iodoform. Then the next one, the ideal solution is formed by mixing 3 moles of A and 1 mole of B, and vapor pressure of the solution is found to be 500 mmHg. After further addition of 1 mole of A, the vapor pressure of the solution increases by 20 mmHg. Find the vapor pressure of pure B. So how we can solve it? So let's take the initial moles, that is 3 plus 1 mole. Correct, 3 moles of A, 1 mole of B. So that is 4 moles. And the pressure, that is 500 mmHg. So after adding 1 mole of A will become 4, and 1 mole of B, so that will be 5 moles now. Now the pressure is increased by 20 mm. That becomes 20 mm, 520 mm. Okay, so we know the formula. PT is equal to chi A PA naught plus chi B PB naught. So substitute the values over here. Chi A, that will be 3 by 4, right? And chi B, that is 1 by 4. So this is our first equation. Similarly, for the after condition, the equation becomes 4 by 5 PA naught plus 1 by 5 PB naught. So this becomes the second equation. So upon solving, you will get pure B, PB value, right? So the PB value will comes out to be 200 mmHg. Okay, so this is the analysis of Jan 23 shift 1 and 2. They have asked moderate level questions. Not so easy, but some problems are a bit lengthy too. So make wise use of your time at the time of examination. Quickly do the problem. If you are stuck with any problem, please skip and come back later. Okay, so if you are the person who are solving physics and chemistry first and the mathematics at the last, so if you are spending more time on numericals in the physics and chemistry, maths you can't be able to complete it. So plan it accordingly. All the best.